Good morning, students. In this video we will discuss single phase AC circuit consisting of L inductance. That means if you connect inductance across AC supply are parallel to the AC supply, what about the power consumption? How about the voltage waveform, current waveform, and phasor difference, phasor representation, and voltage, current, power waveform, and how the inductance behaves if you give AC supply, right? What is inductance or inductive reactance, which opposes the uh, flow of AC current, right? Or which opposes the inductive reactance, okay? Inductive reactance opposes the change in AC current, that is inductance. L is equal to di by dt. That already we studied, right, in the PU classes now. So and also inductance stores the energy in the form of magnetic field, and also energy stored in a magnetic field half Li square derived, right, and half CV square for the capacitor, right? So if we give single phase AC supply, how exactly it will behave, and where we can find this inductance? The next question, right? So inductance we can find, or inductive reactance or choke coil we can find in the two plates, CFL amps and all. For limiting the starting current, for limiting the fast moving electrons, we want inductance. Single phase AC circuits, only one phase neutral will be there, only one waveform will be there, voltage and current. That is called as single phase AC circuits. If it is three phase, three waveforms will be there, and here single phase circuits only. If it is DC, there is no frequency magnitude changes, but here magnitude, frequency, everything will be there, right? So that is called as a single phase AC circuits, alternating current circuits. So this concept is common for all the engineering branches. See one by one derivation of a L circuit. See the circuit diagram. Inductance, pure inductance connected across AC supply, that is V is equal to Vm sin omega t. Equation number 1 I have taken, okay? So supply voltage is V is equal to Vm sin omega t. Due to voltage, current will flow through the circuit, or current will flow through the inductance. That current is I. Initially I have assumed here. Voltage drop across the inductor is VL. VL is equal to I into acL. What about the phasor representation or phasor difference in the pure inductance or pure inductive reactance? So current always lags by voltage at an angle 90 degree, or 5 by 2. Where capacitance current will be leading, but inductance current will be lagging. Current lags by voltage at an angle 90 degree by voltage. So according to this, voltage is equal to L into di by dt. So that V is equal to what? L into di by dt. What about voltage? Voltage is equal to L into di by dt is the voltage across the inductance. Okay, VL is equal to L into di. Not L is equal to di by dt. VL is equal to L into di by dt. So what about V? V is equal to Vm sin omega t. Just I'll substitute over here. So L into di by t. If you want I is equal to Im sin omega t. See, voltage is this one. Voltage is this one, okay? And voltage is this one. So if it is I is equal to Im sin omega t minus pi by 2, or Im sin omega t minus 90, or Im sin omega t minus pi by 2. So if you want instantaneous power, power is equal to Vi. So voltage into current. So we'll get what about power equation? Power is equal to Vi cos phi, right? Vi cos phi. Vi cos phi. So phi is the quotient of angle between voltage and current. So phi difference is cos 90 is 0. So power consumption for pure inductance you will get 0. Okay, this is problem. See here, and waveform also like this. Waveform also like this. This is voltage, this one is exactly 90 degree current. Okay, so current lags by voltage at an angle 5/2. So solve one problem. A pure inductive coils allows a current of 10 amps. Okay, to flow from the 230 volts 50 hertz supply. Find the inductance of the coil, power absorbed by the coil, and equation for voltage and current. See, for this circuit diagram is like this. So this is voltage. Okay, this is inductance. Okay, not resistance. This is inductance. This L is given, current is given 10 amps, and supply voltage is given 230. Right, 230 volts, and 50 hertz supply has given. Inductance of the coil. We need to calculate L of this coil. L is equal to what? So formula directly is not there. acL is equal to what? 2 pi FL. 2 pi FL. Right. So L is equal to acL by 2 pi F. How do you calculate acL? acL is equal to V by I, right? V by I. So that is inductance. And power absorbed by the this one is directly 0, because your inductance is there, power is equal to 0. We don't want the 230 into 200 cos phi is 0, right? Cos 90 is there. Power equation is 0. And equation for voltage and current, V is equal to Vm sin omega t, I is equal to Im sin omega t minus 90, right? So minus 90. So cos 90 is what? 0, right? So solution will be acL is equal to V by I. 230 divided by 10 is 23 ohm. acL is equal to 2 pi FL. L is equal to acL by 2 pi F, and is equal to 0.073 Henry. We got L is equal to 0.073 Henry. Okay, this one 0.073 Henry. And power absorbed by the circuit, power directly can write the power is equal to 0, because power is equal to V I cos phi. So voltage you can substitute, I also you can substitute cos phi. Cos 90 is what? Cos 90 is 0. So power consumption becomes 0 only. Correct, right? So power consumption is 0, right? So Vm is equal to root 2 into Vrms, that is 325.27. So Im is equal to root 2 into I, that is 14.14 amps. Omega is equal to 2 pi F, so 314 radian per second. So V is equal to 325.25 sin 3140, and I is equal to Im sin omega t minus 90. This is the solution for that problem. Okay. So I'll just draw a vector, vector diagram of this L circuit. See, this is voltage, this is current. So this one is 90 degree. Okay. This is voltage, this is current. Current lags by voltage at an angle 90 degree for the inductance. Okay. Current leads by voltage at an angle 90 degree for the capacitance. So the waveforms would be like this. I'll erase everything. Just draw the waveform, power current waveform. So this is x and y axis. This is voltage, and this one is exactly 90 degree. Okay, 90 degree, and here this is 90 degree. And what about the power? Power I can say plus minus. Here power, here both the plus, here again, here this is power. This is voltage, current, power. This is 0. Okay, this is voltage, this is current, this is power. Okay, so this is how we are drawing the diagram for inductance circuit, pure inductance. Okay, power consumption, power absorbed by the circuit becomes 0. Power is equal to 0, because positive half cycle equal to negative half cycle. Positive power is equal to negative power. So power is equal to 0. Power consumption by the pure inductance is equal to 0. Okay, So for inductance also same, for capacitance also same. For resistance only power is equal to V. Consumption occur only in resistance. Thank you so much.